Hi everyone, it's Professor McBain. Welcome to Chem 100 and to our first real lecture of the semester. It's going to be a short one, so let's dive in. Say hi, Betty. Welcome to our first official content lecture of the semester. Chemistry is the study of elements. I like to think of it really as the study of matter, but if you take a piece of matter and you start breaking it down into all of the units that comprise it, eventually you're going to find an element. An element is a fundamental substance that cannot be broken down into simpler substances with chemical changes or just simple physical slicing. Modern theory describes each element as having a unique number of protons in its atomic nucleus. We're going to learn more about that with our activity this week on atomic structure. And then you're going to have plenty of homework problems to help give you all of that practice to help those concepts stick. Back around 400 to 500 BC, Democritus was one of the first people to come up with the idea of what an element is. They called it an atomos. But then modern atomic theory picked it up right around 1808, and then thanks to advances in technology and new pieces of evidence that scientists gradually collected and curated over the years, we now have modern atomic theory. The kanji for chemistry actually means change science. So not only is chemistry the study of the elements, but it's also the study of how substances can change when they interact with each other. Chemistry is often seen as being pretty difficult because, well, we're talking about the world existing in a way that you almost certainly have never thought of before in your life, unless you happen to have been raised by scientists. The reason is that the atoms that make up the materials around us are so small that nobody can see them with the naked eye. Let's hop over to this little interactive from University of Utah. We start off with things that are normal size, and then we zoom in and zoom in and zoom in. Then eventually we can get down to a carbon atom. So I'm going to link this in the YouTube video description below so that you can play around with it yourself. I went through it pretty quick. But I encourage you to take the time to go smaller and smaller and smaller and smaller all on your own, because it's pretty amazing just how small an atom is. I'm also going to link a YouTube video to a TED Talk that goes over that very, very small scale of an atom in a different way. Now, yes, atoms are so small that you can't see them, but nowadays we actually can see them, thanks to, again, advances in technology that allow us to actually see atoms on an atom per atom basis. So all the way on the right is, again, the kanji for chemistry, which is really cool. And these individual iron atoms were arranged on a copper surface with a scanning tunneling microscope. And then you've got another scanning tunneling microscope image that was arranged and then taken an image of by IBM. So that's all that I've got to tell you today. So make sure to watch the TED Talk that I'm linking below, and I'll see you next time.